Good day, Earth Science students. Welcome to video lecture episode 13. Today we're getting back into properties of Earth, in particular the magnetic axis, and then we'll be moving into some other interesting topics in relation. Now, let me just quickly review what we talked about last time, and that is this from slide 31. The location of the magnetic poles has been shown to slowly change over time. The magnetic poles move around the rotational geographic poles in an irregular way. This movement can be significant over decades, that is, a decade is 10 years, just remember that, just in case you were curious about that. Many maps include information about the position of the magnetic North Pole at the time the map was made. So if you have an older map and you compare it to today, now you know why that's the case. Now, just one quick little question I want to ask, and it's on slide 33. Why would this information be important? Why would the information we just been talking about, magnetic axis, both from the beginning of this lecture and from last lecture, why would that be important? Think about that. Alright, let's move into slide 34 and let's talk about what causes changing seasons, or at least let's start discussing it. Flowers bloom as the days get warmer, the sun appears higher in the sky, and daylight lasts longer. Spring seems like a fresh new beginning. So let me ask a question again. What causes these wonderful changes that we just described on slide 34? Think about that. Now let's talk about a subtopic within what causes changing seasons, and that's orbiting the sun. Now we learned earlier in this chapter that Earth's rotation causes day and night, in other words that 24-hour period that we know as a day. Another important motion is revolution, which is Earth's yearly orbit around the sun. Just as the moon is Earth's satellite, Earth is a satellite of the sun as well. If Earth's orbit were a circle with the sun at the center, Earth would maintain a constant distance from the sun. However, this is not the case. Earth's orbit is actually an ellipse, an elongated closed curve. The sun is not at the center of the ellipse, but is a little towards one end, as you see on slide 38, the image I have there. Now because of this, the distance between Earth and the sun changes during Earth's year-long orbit. Earth gets closest to the sun at about 147 million kilometers away around January 3rd, and the farthest Earth gets away from the sun is about 152 million kilometers away, and that happens around July 4th each year. So let me ask a question in light of that information. Does this elliptical orbit cause seasonal temperatures on Earth? Does it? Think about it. Just saying, think about that question for a moment. Does this elliptical orbit cause seasonal temperatures on Earth? If it did, you would expect the warmest day to be in January, and you know this isn't the case in the Northern Hemisphere. So something else must cause the change. Even though Earth is closer to the sun in January, the change in distance is small. Earth is exposed to almost the same amount of sun all year. But the amount of solar energy any one place on Earth receives varies greatly during the year. Let's learn why. Okay? So now let's get into another subtopic, and that is a tilted axis. Earth's axis is tilted 23.5 degrees from a line drawn perpendicular to the plane of its orbit. It is this tilt that causes the seasons. So if you look at slide 45, you can see the image of the Earth and how it's tilted, and how that tilt is what gives us the various seasons. Alright, so let's go ahead and close up our discussion, just mentioning a few other things about a tilted axis. Daylight hours are longer for the hemisphere, or half of the Earth that is tilted towards the sun. Think of how early it gets dark in the winter compared to the summer. Just think about that. Alright, ladies and gentlemen, this concludes our time in lecture. I do hope it has been helpful. If you have any questions, you can leave them in the comments below. Reach out to me via email or message. And I do hope this has been helpful. Have a nice day. Take care.